Our next speaker is Professor Paul D Clough.
So what I thought I'd do is I'll give you a quick kind of introduction to algorithmic bias and maybe why it's come into the limelight at the moment, why it's kind of a topic of great interest. But I guess to kind of give you an example, I wanted to give you a kind of a more concrete case study. So I'm going to take you through a piece of work that we did for a conference a couple of years ago now, where we were looking at gender biases within image search. So I think that's a useful example because it does show you the effect of biases within algorithms and how kind of what's happening in the real world can basically be perpetuated or can find its way onto the digital space. So we'll have a look at that. Then I'll talk briefly about, well, what's being done about it or what could be done about it, and then a summary. So I guess the first place to start is that algorithms are widely used. I mean, they're used pretty much every day in all walks of life, used in business, used for personal use and leisure. And algorithms are very popular. Why? Well, because they can help us in terms of prioritizing stuff, ranking stuff, making predictions, finding patterns association, or filtering. Okay, and in the world in which we live, having features like filtering, being able to search for stuff is really important. And predictive models, the use of being able to kind of make predictions, well, that's seeing its kind of way made into things like personalized recommendations. So if you're using e-commerce tools or if you use Amazon, those types of tools. Credit scoring, maybe you apply for a loan and an algorithm will decide whether the loan should be given to you or not. Also, automated CV screening is something that's very regularly done, especially if you're in a large company and you get a lot of applications that would take a long time to manually work through. And also, we've seen a lot of use on algorithms within the kind of profiling within police. So there's a lot of use for these kind of predictive models, a lot of use for AI in all walks of life. But the problem is, I guess, predictive models are biased. That is, predictive models, AI, can discriminate. That's kind of what we mean by biased. It's a prejudice against a person or a group of people considered to be unfair. And I think there's a problem here because often people assume that an algorithm is objective, that it's not biased. And in one sense, the algorithm isn't biased. I mean, in the simplest, it's just a bunch of rules. In the case of machine learning, well, an algorithm has to be biased because that's how it learns to make decisions. But actually, the problem is the bias comes from what is fed into the system, and then what is around the system, and then how the system is used. So what happens is there's the algorithm in the middle, which may not be biased. It may be completely fair. It may be very objective. The problem is the data that you feed in to the algorithm, into the system, may be biased, whether you know that or not. And then what happens is that you train up the algorithm, so then the algorithm, the model, is biased in some way. And then the problem is the model gets used, and the human that's using it is also biased. So within this kind of quite complex world, there are a whole load of biases going on. The algorithm itself then becomes biased. And the problem is, well, so what, you might ask? So what? Well, this is just one example of a news article. This was from the New Scientist, of cases where algorithms have discriminated. Okay, the bias has actually had an effect on people's lives. That includes around gender. So, for example, Google online advertising was basically shown to show high-income paid jobs to men more than women. So it's biasing there, it's prejudicing. Facebook, in the automated translation software, decided to choose a translation for the Hebrew good morning to attack them. There is a bias there being introduced, a quite serious bias by the machine translation system. There's been examples in the kind of police and in the kind of law courts. So the famous one is a system called Compass, where it was basically found that the tool had a bias against black defendants. So black defendants would either get stronger sentences or would be more likely to get put in jail as opposed to white people. So the problem is the algorithm may not be biased, but what you put into it typically is. The way that you use it is biased, and the effect can be enormous and have great impact on our lives. Now you might be thinking, well, that's all fine, but we're working here in digital libraries, we work in IR, natural language processing and so on, so what? Well, there's been quite a lot of work around the biases that occur also in, for example, natural language processing. So here's a report from a company called Oxford Insights that shows how there are racial biases within natural language processing tools. One example could be within word embeddings. They're very popular at the moment, and they often come pre-trained. And they come pre-trained on data that happens to be biased. Therefore, the word embeddings tend to be biased. So you might make associations like women are homemakers, men go into kind of high-paying jobs. And that is derived from the models that are built upon the data that you have. This is a very good article, actually. I'll share the slides afterwards. It gives you a whole insight to various areas where natural language processing tools, technologies, and so on are biased. There's also bias in library systems as well. So here's an article around the biases that occur in a off-the-shelf, one that you can buy, library discovery system. Where do the biases come in? Well, in discovery systems, we often want to use things like recommendations. So one example of the biases that occur in this, so this is somebody who's done a kind of a case study, if you like, just a hands-on experiment with a library system. The biases that occur are around the recommendations that are given. So you click on an item and it makes recommendations. Those recommendations happen to be actually quite biased, making certain judgments. I have to say, though, I'm not trying to be sort of, putting a wet blanket on anything. I'm not trying to sort of give you all bad news. It's not really all bad news, because I think the main thing from my perspective that's come out a lot of certainly the media around algorithms and around algorithmic bias has been the fact that actually humans are biased. Okay, so it's a myth to think that algorithms are objective, but it's also a myth to think that human processes are not subject to biases. Okay, so any human process has bias. And actually what the kind of algorithmic bias kind of media attention has done has made us rethink, well, actually, humans are biased. They happen to kind of feed data into these algorithms, which make them biased. Their use of the algorithms is biased. It's made us kind of rethink and challenge, okay, human biases. There's a very good book, I'll put a bigger version at the end so you can see it, called Understand, Manage and Prevent Algorithmic Bias. And the first few chapters are given over to human bias, cognitive biases, because that's actually really important, because that affects the algorithms that we are using today. So the fact that you prefer certain items on Google, on the search results, and you click on them, affects the system. Your biases are then fed back into the system. The fact that you click on and buy certain things on a e-commerce site gets fed back into the system, and you become into like a bubble, okay, what we call a filter bubble, okay? So it's not all bad news, but these biases, we need to think about them, and we need to mitigate them, and we need to think about where they exist within our systems. So what I thought I'd do is just to try and make it a bit clearer and give you a more concrete example, was just talk about a study that we did a couple of years ago now. So you can find the paper online. This was at the Computer Human Interaction Conference, CHI, in 2017. I wrote the paper with two co-authors, Jan Ottenbacher from the Open University of Cyprus and Joe Bates from the University of Sheffield in the Information School. And what I'll do is I'll just kind of walk you through the paper. The paper has a lot more detail if you'd kind of like to find out a little bit more. So why were we interested in search? Well, I guess part of the reason is that search is widely used. We all use search technologies, Google or Bing or whatever else. I think also we often treat search as a black box. And often, if you ask people, they will trust the results. If you ask most people, they will assume that Google and other search technologies are not biased. So there is an assumption that the black box is objective, and that is not the case. So there's been plenty of articles in the news. This one's quite an old one. You can find plenty of newer articles today where Google is favouring a particular political party. Okay, or it's assumed that the results are favouring a certain political party. At the moment in the UK, we have the general election ongoing. In fact, it's happening tomorrow. There's a huge amount of interest in analysing kind of what's going on social media and the biases and what's going on in terms of search. People use this to find information, okay? And Google gives us a view of the world. A library gives you a view of the world, and it is somebody's view of the world, okay? But the users treat that as the truth and objective. Social media gives you a certain view on the world. Okay, and those views can be distorted and transformed and changed. And most people don't know that and recognise that. So search is, I think, a very good topic to focus on because it's so widely used and probably so misunderstood as well. So the particular study we were doing was focused around gender stereotypes. Now, there had been some previous work done on this, and this was around kind of gender stereotypes in professions. So if you went onto an image search engine, so this is Bing Images, you could use Google Images, whatever, and you typed in the query nurse, okay, what types of results would you get back? What types of results might you expect to get back? So a previous paper had analysed this and kind of looked at male professions and female professions. And you probably expect that female professions have more pictures of females, male professions more pictures of men. And their paper confirmed this. This is the case. So here, when we look for pictures of nurses, they're predominantly female. In this case, actually, they're predominantly white. They're predominantly pretty, predominantly kind of, middle class. There's a whole load of biases going on here. Okay, so maybe it's not as bad as it looks. I know you can't see that, but Bing gives you a kind of a set of categories. One of the categories is male nurse. Brilliant. Okay, that's pretty good. Let's go and click on that. Maybe that's going to be a little bit better. So this is what we get when we look at male nurses. And okay, we do get pictures of predominantly male nurses. But when you look at the kind of stereotyping literature, there's something that you get called a backlash effect. Now, a backlash effect is people who don't fit the norm. And actually, we see that in this example because the male nurses, some of them are kind of funny. Some of them are kind of a bit jokey, not really being taken seriously. There is a backlash against men being nurses. And we see that in the real world, and we actually see it on the online space as well, in this case on Bing Images. So the image results are biased, okay? Now you might argue and say, well, that reflects reality. Okay, fine, but what if it's our children who are looking on this? I have my son who looks on this who wants to be a nurse. He only sees pictures of girls. Maybe it makes him think, I don't want to be a nurse, it's all girls. Okay? It could actually have quite, serious consequences. Okay, well, let's look at a different search. So the previous work that kind of looked at stereotypes, okay, how we perceive somebody, but they'd only considered occupation. But why don't we sort of broaden it? Because there are other kind of characteristics or traits that we could use. So, for example, in the case of an intelligent person, okay, intelligent person, where's the woman? Okay, there is no woman on the first page of results for this particular query. Okay? So what we tend to find, and we're going to explore this in a moment, what we tend to find is that there are biases being exhibited, okay, in the results. Now this is another search for shy person. So for shy person, we mainly have women. And there are a number of kind of non-kind of images as well. So look at the distribution. It's mainly pictures of women or girls as opposed to men for the query shy person. Okay, so the problem that we had then, or the challenge that we had, is that we wanted to explore this in a kind of more scientific way, but how do we kind of do this when you're dealing with a lot of images? So kind of going through trying to identify whether there's men or women in the images is quite hard, especially if you've got thousands and thousands and thousands of images. So we needed to think of a way of kind of automating this. So the way that we went around this is to use some work from social psychology. So the team comprised of an information scientist and a social scientist as well. And so we were introduced, or we used the kind of work that social psychology has done around stereotyping and perception. So I don't know if you know about the Big Five. Have you heard of the Big Five? Typically the kind of this scale, or these characteristics that are used around personality traits. What type of person are you? And the Big Five are a kind of set of, if you like, characteristics or criteria that could be used to rate you. Well, similar work has been done on kind of perception, how we perceive other people, which informs stereotypes. So our perception of others, it's been found, has been typically based upon two dimensions, if you like. So there's agency or competence, how competent do you appear to be, and also warmth or communality, how warm do you appear to be. And the notion of a stereotype is typically captured by combinations of these two dimensions. So the literature, okay, and this is not from my perspective, but the literature from the psychology has said that women are typically perceived as low agency and high warmth, whereas men are perceived as high agency and low warmth. Okay, that is how people are perceived. Okay, so how are we going to be using this in this particular study? So what we need to do is somehow measure those two. So we have agency and we have warmth, and somehow we need to quantify those and measure them, okay, in relation to what we're trying to do. So the way that we did this was to use an existing technique called the trait adjective checklist method. A bit of quite a trail of words there. But the social psychologists have come up with this method where basically with 68 objectives, okay, people are asked to rate other people. Okay, so it might be an objective, could be competence. So I rate you on a scale of competency. And lots of studies have been done across the world as well. So this is a kind of multicultural approach as well, in terms of coming up with ways of kind of perceiving people or quantifying that perception. And kind of what it ends up with is a list of 68 different adjectives that describe people. Okay, so we've got able, effective, affectionate, altruistic, competent, and so on. And these traits, if you like, are used to form perceptions of people and are therefore used to stereotype people as well. So this is simply sort of how we were going to be doing the study then. So we took these adjectives, these 68 kind of different characteristics, and we were interested to say what types of images would you get back for if I put in the query competent person? Would I get more men? Would I get more women? The literature would say that you would get more men. Okay, that's what's happening in the real world. Does that translate into the into the virtual world, into the digital world? So what we did was basically formed queries out of these 68 different adjectives, and we added the adjective to the word person, or person to the word adjective. So we would type in a query, able person, conscientious person, competent person, and so on. So we put that into Bing Images using the API. So we used Bing Images mainly because it was the only major image search engine that was accessible to us at the time. And then we retrieved the top 1,000 images. Now, in the Bing Images, you can set the search market, where you can say you're interested in searches coming back from India, UK, and across the world. So for this, we tried 4 different markets: UK, US, India, and Africa as well, just to see if there'd be a difference. Now, in the end, I have to say we didn't see a huge difference, but I think that's partly because of the way the API is designed. Ideally, what we need, and maybe you can help me, is we need people in their own countries to do the query, and then we look at the results. Okay, ideally, that's how we need to set this up. Okay, so a couple of questions that we were interested in. First of all, if you just typed in the query person, who do you get back? More pictures of men, more pictures of women. Okay, and then in terms of stereotyping, do we see stereotypes occurring within the results? Okay, so it's quite a challenging process. So you type in a query, get a bunch of results, and we want to ideally automatically go through and say, does the image contain a picture of a man, a woman, or boy, girl, and so on. So to do this, you might think, well, is this even possible for a human to do? So we set up an initial kind of pilot study using a crowd sourcing platform called Crowdflower. And we basically took 1,000 images, and we had 3 annotators per image, and we asked them to basically say, is the image a photo? Is it an illustration? If it's a photo, does it contain pictures of men, women, boys, girls, and so on? And actually we found that the agreement was pretty high in terms of whether in terms of whether it's a photo or whether it's an illustration. I mean, that's quite simple. You can easily tell whether it's a picture or an illustration. Now, what about in terms of gender? Okay, well, for photos, well, again, the agreement is fairly good in terms of, well, for women and girls, maybe less so. The men, it's easier. Quite a lot of unknown. Okay, but we did find that for sketches, it was really hard. You have a kind of a stick person, and you don't really know whether it's a man or woman. So basically, in the rest of the study, we ignore anything that's not a photo. We try and only use the photos. So how do we automate this? Well, we used a tool called Clarify. So Clarify is one of a number of tools that enable you to do kind of face recognition or kind of describe what's in an image. So it's an API that you can have a go at using yourself. So it's a fairly general tool, but we found it worked quite well for pictures of people and saying whether it's men or women. So the idea is that you feed in a picture like this, and Clarify will give you a number of tags associated that ideally describe what's in the image. So it's a person, man, famous, event, entertainment, and so on. Okay, so the fact that we have kind of man and guy in there would enable us to be able to classify the image as being a man or male. To do that, we use something called the Linguistic Inquiry and Word Count Dictionary. So that, for example, has female references. It's like a dictionary of female references, dictionary of male references. So basically what it means then, in terms of the process, is that we have a query, okay, and we have our list of adjectives. So we might type in competent person into Bing, and we get 1,000 results, and we multiply that by each of the markets. Then what we do, okay, so that's our first kind of data gathering part. And then to analyze the images, we use the Clarify API, which generates a textual description. Then we use our dictionary to try and infer whether it's a picture of a man, woman, and so on. Okay, how good is this? Well, we had our kind of 1,000 images that have been manually annotated. And we find that actually the kind of accuracy is fairly good. Now, the precision tends to be better, so it's quite good at being correct, but actually the recall is lower. So there's quite a lot of images that are missed that the humans have kind of said is a male or female. Okay, but this at least enables us to quantify how good our system is before we release it on thousands of images. Okay, so here we go. Here are the results. Okay, is Bing Images biased? Okay, is it gender biased? Well, short answer is yeah. So this is basically the first 100 images. Okay, for the UK, US, India, Africa. Then it's up to 200 images, all the way up to the top 1,000 images. Okay, so the kind of the small grey here is typically the females. The kind of grey in the middle is the male. The white at the top is the unknown, if you like. And so overall, we see that for person, you just type in person into Bing Images, and around 48% of the images depict men, 18% depict women. And that's even worse if we only consider the top 100, and most people don't really go beyond the top 100. It's even more biased if you look at the top 100. Okay? The second question really was around, do we see the kind of stereotypes that are from the literature appearing in the digital world? Okay, so we have these kind of traits. Thank you. We have these kind of traits, if you like, that we know. So we know the literature says that men typically are competent. Okay, and females are considered warm. That is what the kind of stereotypical literature has shown in the past. So that's what happens in the real world. Does it translate into the virtual world? Okay, so what we did is a simple kind of clustering of these traits. Okay, so for each trait we say what are the number of male images that come back, or images that are male, images that are female, or kind of unknown. And we basically group them together, or the algorithm groups them together. So we see, for example, if we look at the green, these are the traits that are most often portrayed for women. So warm is right out there, which means that actually it's very indicative. Most of the images related to that particular kind of query were of women. And we see at the bottom, we've got, on the sort of bottom left, we have the competent. So this kind of competent and warm is often, that's what we entitled the paper. That's often been used in the past in terms of gender stereotypes. So what we see here is it actually plays out. What is in the real world actually makes its way through into the system. It's an algorithm, but the algorithm has been shaped, okay, by people and by the environment in which it's working. Okay, so I should say that the algorithm itself is kind of fairly objective. It's not really biased. There may be some human tweaks in there. The engineers might be using certain types of algorithm. That's a bias. might be using certain parameter weights, that's a bias. But actually search itself, when we talk about web search, is in a whole ecosystem that is very human-centered. Okay, so the data you feed in is biased. The people using the system are biased, and they're feeding back into the system, which makes it more biased. And the end result is that the output is therefore going to be biased. So the output is a reflection, okay, of our reality. What can be done about it? This is a very nice slide from Brown and Draper, where they talk about just asking questions right the way through the kind of design process. This is the kind of machine learning design process. The types of questions that you might ask are, first of all, is the algorithm an ethical choice in terms of solving our problem? So for judges who are making decisions about whether to put people in prison or not, should an algorithm even be used at all? Well, maybe it should be, because it can be more consistent. Maybe it's more consistently biased, but at least it's consistent. Okay, the data that we get, the sampling methods that we use, okay, we have to think about that. Is that going to introduce bias? The training processes, the testing processes, the deployment processes, they can all introduce bias, and we need to think about how we're doing each of those. Okay, kind of solutions that have emerged have included technical solutions. So, for example, IBM have launched a tool that detects bias. Google have a tool that detects bias, Microsoft, and so on. Lots of kind of tools have come about that kind of enable you to detect bias within your kind of training, within the data that you feed into the system. Another topic that's very kind of trendy at the moment, quite rightly so, is explainable AI. When you are given a recommendation in a library discovery system, why were you recommended that particular item? Okay, explainable AI would go a long way towards transparency, being able to understand how these systems have made their decisions. I guess the other area would be around educating people. Okay, so using kind of data literacy, algorithmic literacy, to help people understand the kind of, if you like, the value chain of algorithms. Okay, people perceive algorithms as digital systems, Facebook and so on, Google being non-biased, but they are. And people need to understand that. People need to start basically thinking about the kind of quality of the material that they're fed. Okay, it's going to be biased, so dealing with misinformation, fake news, and so on. There are lots of educational programs going on at the moment. So there's a conference called the ACM FAT Conference, Fairness, Accountability, and Transparency. That's going on next year. It's been going for a few years now. And ourselves, we're involved in an EU-funded project based in Cyprus, which is all about setting up a centre around algorithmic transparency and educating teachers around the kind of, the problems within digital technology. This is an example from Microsoft, who have now set up their FATE, I don't know if that's a great acronym, but their FATE department. So fairness, accountability, transparency, and ethics in AI. So, for example, have you asked for consent from somebody now you're using their data? Is a really important thing to be thinking about when you're using algorithms. Governance and transparency is a massive area that needs to be thought through. The self-driving car crashes and kills somebody. Whose fault is it? Is it the car manufacturer? Is it the government? Is it the AI developer? The library recommender system, okay, points you to a kind of a biased or sexist recommendation. Whose fault is it? Or it points you to an item that is not in copyright and you go and misuse it. Whose fault is it? Okay, so we need to be asking these questions around kind of accountability. Okay, and lawyers, we've seen a great talk in this conference on kind of sort of copyright and some of the issues involved there. I think it gets even more complex when we think about algorithms and algorithmic bias and kind of, the governance and the kind of transparency within algorithms. Okay, so in summary, where are we at? Well, decision making is increasingly data-driven, and that can include the kind of, affecting you in your daily lives. Algorithms are commonly being used and employed to help people with those decision processes. But like humans, algorithms are biased. Not in their own right, but because the humans that are generating the data, the training data that goes into the system, are going to be biased. Okay, and the problem is that the digital system then perpetuates bias, and we've seen one example with image search and gender stereotypes. And there are lots of solutions needed. They need to be technical, they need to be educational, they need to be government solutions as well. But I think it's important to remember we can only expose, measure and try and reduce bias. We can't really completely eradicate bias, particularly algorithmic bias, because, well, people are biased, and we always will be. But we certainly need to raise awareness. So if you want to find out more, here's a couple of sources that if you haven't come across them or read them, I do recommend them. So the first one by Cathy O'Neill is called Weapons of Math Destruction. And it really is an enlightening read. It takes you through great examples of where AI has basically prejudiced and discriminated people. And it's quite frightening, actually, when you read it, because it's the systems that we are using ourselves. This is a new book that's just come out called Understand, Manage and Prevent Algorithmic Bias. A really good overview of the kind of human biases and the kind of algorithmic biases and some of the ways that you can kind of manage that. And then if you want maybe a lighter read and a shorter read, a few months ago I wrote just a shorter article for business on bias in AI and machine learning. And if you want a few other links and stuff, then go and have a look at that. Thank you.
Thanks, Bob. My take on your deliberation would be web is a true reflection of human society, and as the algorithms are using the data from the web, they are getting all the blames, and the AI researchers, they are really looking forward to how to eradicate this bias, may not be eradicating it in full way. So time for a couple of questions before we leave for the lunch break. Okay.
Thank you, Paul, for such a wonderful presentation. But I think that 73% you have mentioned in your slide.
Sorry.
73% that image data is accurate, others are not. So that is alarming as far as gender bias is concerned.
Yeah, so I mean, that's a really, can I just ask, because that's a really good point in terms of one issue with our methodology is that we're using an automated technique, okay, that's been trained on biased data to recognise men and women. Okay, so, and this is really challenging because then how on earth do you kind of deal with that? So one approach we should do is probably use multiple services, systems, and kind of aggregate the results. Okay, but even as a human problem, it's quite challenging. So thank you for that.
Yeah, I think more workshops related to algorithm, education should be there because many of them, myself, are not aware.
Yeah.
Thank you.
Yeah.
Thank you.
Thanks. I'm from IIT Delhi. I'm just sharing my experience with Library Discovery Service. It's my practical experience. We have been using a discovery service here, but what the practically we are finding that a particular result which are showing on the first page are not as relevant as the users require. And that particular discovery service doesn't provide the result of some important databases or the services which the library is subscribing. That's an alarming thing, and of course we know that there is an algorithm bias, but is there any solution for that? Because that's the important thing, because as you said that the human is primarily the person who is developing the program might be biased in nature. But in my opinion, there are the organizations which are also putting some biasness in their program to make their product sell and serviceable sellable.
Oh, thank
so
you.
my thing is that what's the solution for that basically? Because when there will be more AI, ML, then this thing will increase. Then how can you overcome it?
I think that's a great question, and how we overcome it, I think, is a real challenge to the whole kind of AI machine learning community and wider as well, because it's in any community that's making use of AI machine learning tools. So how do we overcome it? I don't know. I don't think it's a simple solution. I don't think you can just press a button and so on, because there's so many kind of issues involved and ingrained within it. But certainly things like the Microsoft Fate Group, the ACM have produced kind of guidelines on the use of algorithms and kind of algorithmic governance in the UK, and in Europe we have GDPR, and within GDPR, which is the governance of data, we also have consent from users. We also have things like how algorithms should be used, and transparency forms a big part. But you know, at the moment, that is a kind of guideline from the government. It's not in law, and until it becomes law, maybe people aren't going to pay any attention to it. So I don't think there is an easy solution, to be honest.
So I know you said there's no easy solution, but just to push a little on that. So there are things that we are looking at right now. It's okay. So gender, we can perhaps design some solutions to make sure that there is no gender bias. Then you go into race. Then you go into maybe economic biases. And then you see where I'm going. And so then you go into, well, this guy doesn't have hair. And law right now possibly makes some of those illegal. But there are other biases that are not. So do we need to do this, in your view, at least in the short term, on a case-by-case basis to attack these things? Or is there any hope of doing something more generic?
Thanks, Prasanjit. I mean, I think there's a mixture of answers. In one sense, it has to be a case-by-case basis, I think, partly because every case has a certain kind of setup. You know, there are certain issues and so on with each one. So we've done this study on gender biases and gender stereotyping. So our next move was to start to do it on kind of racial bias, but actually trying to find a automated tool that would decide the race of somebody. If you could, we couldn't find one. It's actually really challenging. So again, I think you have to sort of, maybe we've started quite simply, but I do think you would have to move on a case-by-case basis. I think the guidelines that are produced by organisations like ACM are a step towards a kind of generic understanding. And I think, so we run a course at Sheffield on a Masters in Data Science, and we take quite a social sciencey perspective, but one of the core modules is data and society. And it's all around teaching the data scientists that are going to be going out building these algorithms around things like ethics, around privacy. And so actually I think what we need to do is kind of start ingraining it in people's minds, so in the programs that we teach and so on. But that's a radical shift, that's a massive shift. So I think that's a general kind of movement, and it is happening slowly with things like the FAT conference, but it's going to take time. But we still need to look at, I think, a case-by-case basis as well. Thank you, though.
Thanks, Paul. We have enough food for thought for the lunch break.
Thank you, speakers and chair, for conducting such an exciting session.